Hi guys, so in this video we'll be solving this problem, swap all odd and even bits. Okay, so let's first understand what the problem says. So according to problem we will be given a number n. So let me write the binary representation of the number. So let the number be something like this: 1 1 0 0 1 0 1 4 5 6 7. Let's take one more bit, 8. Okay, so what we have to do is that we have to swap the bits at odd and even position. So these are the bits at odd position. This is first bit, this is second, this is third, this is fourth, fifth, sixth, seventh and eighth. So odd bits are what? 1 second. Yeah, so odd bits are 1 3 5 and 7, and even bits are 8 6 4 and 2. So we have to swap the bits at these positions. Okay, so after swapping it will be something like this. If we swap the bits at 1 and 2 position, it will be get converted to what? Something like this: 0 1. If we swap these two bits, these will be what? Again 0 and 1. These are zeros and 0, these are 1 and 1. So our result should be something like this after swapping the bits at odd and even positions. Okay, so this was for the problem part. Now let's see how we can solve this problem. So what we are going to do to solve this problem is that we need two things. We need all the bits which are at the odd positions and all the bits which are at the even positions. Okay, so for that we'll need two masks. Let's suppose there is a mask. There is a mask with the name odd mask. Odd mask will help us to find the bits which are at the odd positions. Okay, and there will be an even mask which will help us to find the bits at the odd even positions. Okay, so first let's extract the bits at the odd positions. So odd positions are what? The positions 1 3 5 and 7. So what we'll do, we need something, we need a mask something like this. If we want the bits at odd positions, so we want something like this one. Okay, and we want the bits at odd positions, means bits at odd positions will be preserved. Like here 0 will be there, so after doing some operations here result should also be 0. At 3 position 0 is there, so result should be 0. At 5 position 0 is there, so result should be 0. At 7 position 1 is there, so 1 should be there. Okay, and the even position should get converted to 0. That, like here it is all 1, but it should get converted to 0 bit. 4 position here it is 1, but it should convert it to 0. 6 is 0, so it will remain 0 only. 8 is 1, but it should convert it to 0. So this is what the role of even mask is. That odd mask is. Odd mask means it will preserve the bits at odd positions, but it will means unset the bits which are at the even position. So this is what the role of odd mask is. So now let's see how are we going to do this. So first let's find the bits at the odd position. So for that we need a mask something like this. Here it will be 1 1 1 and 1. Okay, and rest all bits should be 0. Okay, so this is what, this is our even mask. This is our, sorry, not even, this is our odd mask. So let's write it over here also. Our odd mask is something like this: 0 1 0 1 0 1 0 1, something like this. We have taken 8 bits, so here there are 8 bits. If there will be more bits, so this will continue on. Okay, so okay, so after this what we need to do, we need to perform an AND operation between the number and this mask. So after performing the AND operation, what we will get, since it is an odd mask, so all the odd bits will be preserved. So 0, even if you see the AND operation, 0 and 1 is what? 0. This bit is preserved, right? 0 and 1 is what? 0. This bit is preserved, right? Then 0 and 1 is what? 0. This bit is preserved, right? 1 and 1 is what? 1. This bit is preserved, right? Now all the even bits should be unset. If the bit is 1, then it should get converted to 0. Let's see, 0 and 1, 0 and 1. If you perform the AND, it will get converted to 0. It got unset, right? Same here also. Same, 0 and 0 is already 0. So bit was already unset, so no need to change, means it was already unset. And 0 and 1 is what? And is 1 0. Again the bit got unset. Okay, so this is the number which we got after performing the AND operation with the odd mask. And this is what, in this particular number all the odd bits are preserved and even bits are not preserved. Okay, So let's take it over here. We'll need it later. So let's keep it aside. So this is the number in which we have preserved what? All the odd positions. Okay. Now let's do the same thing for even position. What we need this time? This time we need a even mask. Even mask means what? It will preserve all the bits at the even positions, but it will unset the bits at the odd position. So it need to preserve the bits at the even position. So the mask will be something like this. At even positions it will be 1. Okay, here it will be 1, and odd position should be unset, so it will be 0 at odd positions. Okay, now what we need to do, we perform the AND operations. So all the even positions should be preserved. So 1 and 1 is what? 1. Even position is preserved. 1 and 4 is what? 1. Even position preserved. 1 and 6 is what? 0. Even position preserved. 1 and 8 is what? 1. Even position preserved. Okay, now 0 and 0, 0. Already it was 0, so no need to, means already it is 0. Already bit is unset. Here also already odd bit is unset. Here the odd bit is not unset, but 0 and 1 will unset it. Okay, so all odd bits got unset. So let's write even mask also. What is the even mask? Even mask is something like this: 1 0 1 0 1 0 1 0. Okay, so this is what the even mask is. So after doing this, what we got? This is the number in which we have preserved all the even bits. Okay, so let's move it over here. We'll need it. This is the number in which all the even bits are preserved. Now what we have to do, what our task was to swap odd and even bits. Odd and even bits. So this is a even bit, so this should come to this location, and this is an so this is an odd bit, so it should come to even location, and this is an even bit, this should come to odd location. So what will happen is that if we perform a right shift operation on the even blocks, means even bits, what will happen? Each bit will what? Shift by one location. Each bit will shift by one location. Similarly, if we perform a left shift operation on odd bits, what will happen? Each bit will shift by what? One location. After that, what we will do? If we perform the OR operation, we will get each bits odd and even bits, right? So this is what we are going to do. What we will do is that we will perform a left shift operation on even odd bits. On odd bit we'll perform what? A left shift operation, and on even bits what we'll perform? We'll perform a right shift operation. So if we perform on odd bits a left shift operation, it will get converted to something like this: 1 0 0 0 0 0 and 0. Okay, and if we perform right shift on even bits, it will get converted to something like this: 1 0 0 0 1 0 1 and a 0. Now if we perform an OR operation, what we will get? 0 or 1. We are performing an OR operation. So 0 or 1 is what? 1. 0 or 0 is 0. 0 or 1 is 1. 0 or 0 is 0. 0 0 1 and 1. So this is the result we are getting. Okay, now let's see whether it is same as the original result or not. So what was our number? So this was our number. So if we swap the bits, like let's see one by one. If we swap these two bits, 1 and 1 should be there. Here also 1 and 1 is present. Okay, if we swap these two bits, 0 and 0 should be there. Here also 0 and 0 is there. That is okay. If we swap 1 and 0, what we should get? 0 and 1, and we are getting 0 and 1. That is okay. Here it is 1 and 0. If we swap them, we should get 0 and 1, and we are getting 0 and 1. So this is working. So this is what we are going to do. So this was like pretty easy. What we have to do, we have to make an even mask, extract even bits. We have to make an odd mask, extract odd bits. Then we have to simply perform the OR operation. All the task is that what we have to do is now we have to make this odd mask and even mask, and how we are going to do that is our main task now. Okay, so for that we are going to use like hexadecimal number system. So before moving on to hexadecimal number system, we first know how to write hexadecimal number system. So if we want to write simply integer, what we write? Integer a equals to 324. Okay, but if we want to write hexadecimal numbers, we'll have to write something like this: integer a equals to, we have to start with 0 and x. 0 and x indicates that it is an hexadecimal number. Okay, so after 0 and x, if I write 1 2 3, then compiler will come to know, that means get to know that this is an hexadecimal number, this is not an integer number. So if we want to write hexadecimal number, we should always start with 0x followed by the number we want to write. Okay, so this is how we should write it. Now let's see, like in hexadecimal, what happens is hexadecimal number base is what, 16, and number are written in pair, means in 4-bit. Okay, in 4 bits numbers are written in hexadecimal system. So if we write numbers in hexadecimal system, 0 not 0 1 2, it will be all zeros. 0 1 2 3 4 5 6 7 8 9, so it will be 0 0 0 0 0 1. Okay, and double zero, four zeros. Okay, 9. After 9, there is no 10 in hexadecimal system. So we have A. A is for 10. Like we do not have 10, we have A. So it will be what? 1 0 1 0. Then we have B for 11. So 11 will be 8, 9, 10, 11, 12. 12 will 12 means C is there for 12. So 12 will be 8 and 4. Then 13 is there. 13 means 8 4 0. Then 14 is there, and 14 is for uh okay, then 15 is there, and for 15 we have 1110. Okay, so this is what the numbers in hexadecimal system are. So what is our mask? If we look clearly at our mask, we need something like this: 0 1 0 1 0 1 0 1. Then if there are more bits, we again want 0 1 0 1 0 1 0 1, and so on. So for odd mask, if we look at over here, 0 1 0 1 5. Okay, 5 is written as 0101, and it is of 4 bits. Okay, and if we are dealing with 32 bits and we want an odd masks, then what we have to write? For odd mask, we'll have to write something like this: 0x, 0x is for hexadecimal, then 5. 5 is of 4 bits, and total how many bits are there? 32. So we'll have to write 5 8 times: 1 2 3 4 5 6 7 8. Okay, similarly we want even mask. So for even mask, what will happen? We want something like this: 1 0 1 0 1 0 1 0. So if we look clearly, 1 0 1 0 1 0 1 0, yeah, A is of 1 0 1 0. So we want A 0x, and we want 32 bits. 1 is of 4 bits. We want 8 A's: 1 2 3 4 5 6 7 8. Okay, since 8 into 4 is what, 32, so we'll get 32 bits. Okay, so this is what we can use for even mask and odd mask. So we will be able to generate the masks. After generating the mask, task is pretty simple. So now let's move on to the coding part and let's try to code this problem. So we will be given an integer n. Okay, so let's make an odd mask. Odd mask to preserve. What is odd mask? 0x 0 x, then 5 1 2 3 4 5 6 7 8. And now we want an even mask. Even mask will be what? 0x, then a 1 2 3 4 5 6 7 8. Okay, now let's get the odd number, that is odd bits. So odd bits will be what? We'll simply perform the AND operation with the odd mask. So number and odd mask, and we'll get the even number. Even number will be what? N and even mask. Okay, after that, what we did, if you see over here, we perform left shift on odd operation and right shift on even operation. So odd equals to odd, left shift 1, and even equals to even, right shift 1. Okay, after that our answer was simply the OR between them. So answer equals to even or odd, and we simply print the answer. See out answer, and then let's try to run this code. We are getting correct answer. Let's try to submit it. So it is passing all the test cases. So this was for this particular video. I hope you guys would have enjoyed the video.